Welcome to Alchem, helping you understand chemistry one step at a time. In this video, I want to go through the easiest way to draw and name the carboxylic acids and esters. About carboxylic acid is that this carboxyl group, it has a C2O oxygen, which is called carbonyl group, but it also comes with the OH group together. So always try to view as a COOH together, and I'll call it COO from sometimes. And this group will always be found at the end of the chain. So you need to look for the left and right, but let's actually put this to the end, to the right, and the carbon that has the COOH group should always be the number one carbon when you start counting the main chain. So I'll be adding a few more carbons, and today we'll be dealing with 6 carbons, so I can show you how the branching works. So filling up with hydrogens, and you will end up with a double amount of hydrogen to number of carbons. So the molecular formula is C6H12O2, and the suffix ends with ANOIC acid, so anoic acid, and having 6 carbons in the main chain, the longest chain that contains the functional group, we bring the prefix hex. So that's pretty straightforward. So condensed formula could be reading from the left to right. This is just a shortened version of formula that is written without the sticks to represent the covalent bond. So the one that you see in the diagram is called structural formula, and the one you see at the bottom is a condensed formula. So we go from CH3 and we get consecutive CH2s 4 times from the carbon number 5 to carbon number 2, and always try to finish with COOH at the end. So that's COO again. Some people try to do the CO little 2H, but try to avoid that. Yeah, it's also working. You're not going to get any penalty, but COOH is fine. And you can see the molecular formula on the far right, which uses brackets to represent the consecutive 4 CH2 groups. And here, molecular formula as we have seen. And now today we're introducing something called empirical formula, which happens to be the simplest ratio. So if you look at the molecular formula of having 6, 12, and 2, and you can find the common factor, which is 2, and divide this by 2, and that gives you a simplest ratio of empirical formula. So empirical formula is quite different from the structural formula because there is no 3 carbons, there are 6. But this will be really helpful later for you to do something called mass spectroscopy or finding out the percentage composition by mass and so on. So check my other videos for this empirical formula and see how it works with the molecular formula. Let's add a little twist to this C6H12O2. This is a second isomer dealing with only 5 carbons in the main backbone chain, or this is the longest main chain. And identify this carboxyl group, COO, and this is your number 1 carbon, and there are 5 in the main chain, so the main chain will be called pentanoic acid. Pent is a prefix for 5, anoic acid is a suffix for the carboxylic acid. Then where's the 6th carbon? And I'm going to introduce as a branch here, coming off the 4th carbon of the main chain and filling up with hydrogens. And if you could count, there will be 12 hydrogens as the previous one. And the methyl group, meth is 1 carbon, and the YL is actually an indication of a side chain. So that means 1 carbon is hanging off the main chain. It's just dangling off as a side chain. And we need to give them a location of where it can fall off, where it branches off. And it's coming from the 4th carbon, so it's a 4- or 4- methyl pentanoic acid. And of course, if you have the methyl group on number 3, it's called 3-methyl, and if you shuffle that along to the 2nd carbon, it could also be called 2-methyl pentanoic acid. So feel free to draw the side chain wherever it can go along the main chain, and that'll sort out the branching. Let's see what else we can do with 6 carbons and 12 hydrogen with 2 oxygen here. So shortening it down to 4 carbons. So now you should be familiar with the drill. So 2 remaining carbon, I'm going to, the main chain is going to be a butanoic acid, but for 4 carbons as a prefix. So remaining 2 carbons could be coming as a branch. So there's your first one and there's your second one. I mean, they can go anywhere as long as they're on 2nd and 3rd carbon. number 1 carbon, which already has 4 bonds, there's no capacity to accommodate more atoms there, so it can't go there. But if you have a methyl chain coming off the 4th carbon, it is no longer a branch, it's an extension of the main branch, so it'll go back to pentanoic acid again. So let's add all the hydrogens. I've been counting 12 hydrogens all together, and we have methyl group twice as highlighted in green. So that's a methyl. By having it twice, we're going to put dimethyl. So you can guess it. So di means 2 of the same thing. And where are they coming off from? They're coming off from the 3 carbon, not carbon number 3. Both of them are off. So make sure you do 3, 3. I see so many students just putting 3 once, but you need to give a location of all side chains. So it's 3 and 3 dimethyl. And try to have a hyphen between the number and the alphabet. And if it's 2 or more numbers, try to have a comma between them. Let's go backwards. Imagining drawing this structure yourself instead of naming it like the previous slides. So the name is quite long, so it's important for you to identify and divide the name into what is the backbone, what is the main chain, and what the side chain is going to be. So having this butanoic acid, have 4 carbons drawn with a carboxyl group at the end. You can draw them on the left, but I'm just going to keep it on the right. And try to fill up where the rest of the carbon goes. So have a look at the dimethyl group. Oh, I haven't highlighted the L. So we got 2 carbons hanging off, 1 and 1 separately on the second carbon. So there's your 2, and having 2 and 2, so numbering the main chain, and you just put the side chain on the second carbon, another side chain on the second carbon too, and try to fill up with hydrogen, so making sure that carbon has 4 bonds. So there you are, and if you count them, it'll still end up being 12 hydrogens altogether, and so it will have the same molecular formula. And carboxylic acid has a really, really terrible smell. So simply, if you look at ethanoic acid, which only has 2 carbons, it smells vinegary. It is what's in vinegar. Vinegar is pretty much 4% ethanoic acid solution. But if you have different number of carbon, it smell is quite different. For example, butanoic acid smells so pukey. So it just totally smells like vomit. And 2,2-dimethyl butanoic acid will smell pretty much equally bad too. Okay, let's look at another alternative. So carboxylic acid, 1, 2, 3, 4. But this time I'll be putting the side chain somewhere else. So 1 methyl group on the second carbon and the other one on the third carbon. And some of you might ask, do you have to draw the methyl group on the same side? Not really, because if you shift them to the other side, that'll still be equivalent because carbon to carbon single bonds are able to rotate. So you can actually spin them around, doesn't really matter. And naturally, they will exist in alternating matter like this to avoid any repulsion between electron clouds. But it doesn't really matter how you draw it. So we got methyl group, methyl group. So in this one, I won't bother to do the diagram of hydrogens. So just showing the carbons here. And there's a dimethyl group, as you have guessed, coming off the second and third carbon. So we do have 2, 3 dimethyl. But since it's so easy, I'm going to introduce the condensed formula again. I want you to have a look at how this works. So we're starting with brackets, which is quite confusing. So CH3 twice, followed by CH brackets CH3. That's a side chain dangling off in green at the moment, and the Q for the carboxyl group. And let's see where the bracket's coming from. So if you look at those 2 carbons, I know one of them is part of the main chain. The one is actually the part of the dangly side chain. But if you try to see from this point of view where the arrows are pointing, so that chain is introduced by 2 of the CH3 groups, followed by the C3 carbon. So that's how you can actually do the condensed formula there. And skeletal formula doesn't show any hydrogen, it just shows carbon with oxygen and other main functional groups here. So having 4 carbons, there's your exam tip. So instead of drawing more lines or less lines, because that's a very, very common mistake for the skeletal formula, just try tiny little dot with your pencil. So having 4 carbons in the main chain And once you've got 4 located, just join them to show this is the butane so far. And now we're going to address the double O, and there's your OH. If you don't put the OH, that means there's an extra carbon. So make sure you put the OH. So try to indicate whatever that's not carbon there. And what about the side chain coming off the second one and third one? Just put another long stick, and you don't have to put C because at the end of each stick represent the presence of carbon too. If you study IB, AP, or something equivalent towards medicine or any healthcare profession, we'll be looking at the structure that has more than 2 functional groups. And if you take biology, you might be aware of this term called amino acids. You've guessed it, amino is actually a prefix for the amine group, something amine, and acid is the suffix for the carboxylic acid. This means this group will have 2 different functional groups, one's an amine and one's a carboxylic acid. So on the left, let's do carbons and hydrogens here. So this is the main backbone of the amino acid, and what I'm about to add at the bottom of this carbon determines which amino acid it will be. So I'm just going to deliberately add 2 more carbons here, and we do see 4 carbons in a row. So make sure those 2 carbons that are dangling off, it's not actually the side chain, that's actually an extension of the longer chain. So don't be fooled by the way it's been drawn. Just try to locate as many carbon as possible that's actually in a continuous chain. So that's got 4 carbons, and numbering always starts from the carboxyl end. Because when you have an amine group and carboxylic acid, the oxygen containing group takes the priority. So the amine becomes a prefix instead of the main chain. So there's your 1, 2, 3, 4. Again, you know it's going to be butanoic acid. But the amine group is coming off. This NH2 group is the amine group coming off the second carbon of the main chain. So we just call this 2-amino-butanoic acid. Now I think you have mastered the carboxylic acid. So let's move on to esters. So looking at this isomer of C6H12O2, this molecular formula looks exactly the same as carboxylic acid, which means esters are functional isomers to carboxylic acid. This means they've got the same number of each type of atoms, 6 carbons, 12 hydrogen, and 2 oxygens, but they differ in functional groups, so they are examples of functional isomers. So here what we are looking for is instead of COOH, C-O-O-H, it's actually COOH, C-O-O, and singly bonded to O. And instead of hydrogen to terminate the chain, there will be more carbons to extend the chain. And let's fill up with hydrogen. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here you are proving 12 hydrogens too. And identifying ester, always try to circle the ester group that has 2 oxygens and a carbon. And that will be the start of the main chain. And we've only got 1 carbon ester here. So that's going to be called methanoate. So meth is the prefix for 1 carbon. Anoate is going to be an ester suffix. And be mindful, we got 5 carbons coming off as a side chain, and that'll be named as a pentyl. No numbering is necessary because it's coming off from the oxygen. So pen for 5, YL for the side chain. And you might wonder, why do we not pick the longest chain? And ester is the one where side chain can be longer than the main chain. So it's going to be called pentyl methanoate. And one thing that you need to be mindful of esters are, just like the carboxylic acid and other organic compounds, they smell awful. But ester is one of the fruity, sweet, flowery scent compounds here, which are used in perfumes, food additives, flavoring. So if you purchase any banana milk, they are actually banana flavored milk because they don't have a single bit of banana in it. Instead, they make the synthetic ester that smells like banana, or same with the strawberry milk. Hardly any supermarket sells the milk that has the kind of real strawberry in it. So it must have the strawberry flavored ester to mimic that structure and the smell. All right, let's see the variation of the esters. So one thing that I want you to take away from this video is start counting from the carbon that is in the ester linkage. Sometimes it's called ester linkage instead of esters because it's always in the middle of the chain, and this linkage is formed when carboxylic acid reacts with alcohol as a result, which we're going to cover in another video called condensation reaction. So we got one ester, actually we got one carbon in this ester, but let's add more carbons to it. And this is your ester group. Make sure you circle this. This is the carbon that becomes number one. But try to make up for the 6 carbons. I'm going to add 3 more carbons, so we have 6 carbons altogether. So believe or not, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There you are. It's another isomer. So having 2 carbon ester, what will be the prefix? Eth. That's correct. And having the ester, it's an anoate, so it's going to be ethanoate for the main chain. And we have 4 carbons as a side chain, so that's going to be a butyl. Remember, there's no numbering either. Okay, let's do a couple more. What about if you get a name, propyl or propyl propanoate? So prop, so we got 3, 3, which adds up to 6 carbons. So try to divide the name up so you know which one's the main chain, which one's a side chain. So we got propanoate accompanying 3 carbons, including the ester linkage. And there will be propyl or propyl group bringing 3 carbons as a side chain, and adding hydrogens will add up to 12. So here we have propyl propanoate, and try to add hydrogens to make sure the carbon has 4 bonds coming off. And remember, this is another physical property of esters. They're actually quite nonpolar because of an even spread of electrons across this ester linkage. So they don't form hydrogen bonding with water, so they do not dissolve in water, so they are insoluble in water. Instead, they'll be fat soluble. Just think about aroma oils where it feels quite oily, and that's because it has nonpolar esters, and different mixture of esters will create different scent, obviously. Okay, almost reaching the end of the combination with 6 carbons, and here it's called ethyl butanoate. So let's remember the tactic from the previous one, identifying the backbone butanoate bringing 4 carbons, and the ethyl, which is 2 carbon as a side chain. So this 2 carbon has to come off the oxygen that's been singly bonded, because oxygen could have 2 bonds, but the other oxygen has already double bonds, so there's no space for any atoms to be added. And finishing off with hydrogens, and make sure you look at each carbon, and each carbon has 4 bonds, so think of hydrogen as a filler. And another physical property here, esters are usually less dense. And because it's non-polar, they have lower density than water. So they always float on top of water if you try to add mix esters and water. So imagine when you have a water bath and trying to add aroma oils or essential oils, which contains the fragrance, it must come from esters too. So they always will float on top. Now you know how esters work, so let's try if you can name this. So you count the number of carbons by identifying the ester group, and I'll be adding 1 more carbon here to make up for 6 carbons, because we're going through all isomers that you can draw. So while I put hydrogens, why don't you take a moment and try to name this yourself? If you start with pentanol 8 as a main chain and there's a methyl group, well done. Now you are ready to step up to the next level. And this structure will deal with 3 functional groups, not 2, 3. So can you already see there's a carboxylic acid group? And there's the OH group. If you have seen my previous videos, or if you already know this is actually the alcohol family, the hydroxy group. So here, hydroxy alcohol, we call this hydroxy because carboxylic acid takes the priority because of it's got double bond within the main functional group. So here you are, start counting from the carbon with the carboxyl group, 1, 2, 3, 4. So that means the alcohol or the hydroxyl group is coming off the 4th carbon. So butanoic acid will be the backbone, and we will have 4-hydroxy as a prefix. What about if I add an amino group that you have seen? So this is the amine group, but again, the carboxyl group taking the priority, it has to become a prefix as amino, coming off the 3rd carbon of the main chain. So this will be a 3-amino 4-hydroxy butanoic acid. Notice that there are dashes or this hyphen between the alphabet and the numerical number. Practice makes it perfect. So I'm going to give it a little twist by putting the amino group, amine group somewhere else, and the hydroxy somewhere else. And that'll completely change the naming system. So again, we need to still prioritize the carboxyl group because of the C-double-O bond. And that's your alcohol again, amine, and counting is exactly the same because we need to actually have the carboxylic acid as a backbone. But notice that there's, I'm going to put hydrogens in there to make sure it's all right. And notice that I've got 4-amino 2-hydroxy butanoic acid. So it's not reading from left to right, that when you have multiple side chains, it's not about prioritizing the numbering of the main chain. It actually comes down to the alphabetical order. So amino group starts with A, so that comes before hydroxy group for H. Just reiterating, when you have multiple side chains, make sure you look at the alphabetical order. So I've tried to find all the side chain that could follow this alphabetical order. So if you have amino group, bromo group, chloro, ethyl, fluoro, hydroxy for the alcohol group, iodo for the still halogenoalkane or haloalkane, and methyl. So whenever you have a multiple side chains, try to put them by the alphabetical order. So if this video has helped you a little bit, this is the job done, and I want to really help you to get the highest grade. So keep working, strive for your best. There's nothing you can't do in this world. So trust yourself. Okay, and I'll see you in the next lesson. Thank you for watching.